So how does virtual memory work? So we need to understand the virtual memory technique is actually trying to perform a mapping between the virtual memory and the real physical memory. So of course, there's two types of memory address. One is the virtual memory address, one is the physical memory address. So the virtual memory address is called virtual address or VA, and the physical address is called PA. So the physical memory can be any size, but the virtual memory, we always assume there are 2 to 32 different byte location, So how does the program access the memory? The program execute a load specified by the virtual address. So just as we have a load LW, for example, for MIPS instruction, and then we would like to load from a particular memory address, such as 1024. So that is a real, that is a 32-bit virtual address, 32 bits virtual address. So the computer would like to translate that address into the real physical address. So by using the translation table here, So the physical address, suppose it is not inside of the memory, then the operating system could load it from the hard disk and put it into the memory. So the real address you are actually using could be inside of the RAM, could be mapped to hard disk. And for example, if you are trying to use 4 pieces of data, but you only have 3 pieces data in space in the RAM, then you probably have something mapped into the hard disk. And then the operating system could reorganize this, could put the data which is more often used into the RAM. As long as you have this, you manage this table, you maintain this table all the time, and then you can use this table to get access to all the different address. So for example, suppose we're trying to load from virtual address 512. So the virtual address 512 actually is mapped to the physical address 12. So according to the mapping, the table here, according to the table, and then we will actually load the data from the real address, physical address 12 of the RAM. And another example, so suppose we would like to read from virtual address 786. And according to the table, this piece of data is not currently inside of the RAM. It is actually in the hard disk. So what we can do is the operating system could help to load that piece of data from the hard disk and put it into the RAM. Suppose you do have some location of the RAM is able to be used. So you have some certain location available in the RAM. So the operating system could help to load that piece of data from the hard disk and put it in the RAM. And then our mapping table will be updated. Because currently it is the virtual address 786, the data of virtual address 786 is not in the hard disk anymore, it is in the RAM. So we could keep updating this mapping table. And then to hold, to keep a good record of this table and to make everything more efficient. So even you have only limited amount of space in the RAM, you could still have a program which need a lot of memory, right? So a question, what address is loaded? For example, suppose R12 has R12 is the name of a register. So a register has the value 1536. The program issues load from that address. What location in the RAM is accessed? So according to the program, we only see load from certain address, and the address here is 1536. And then the virtual address is given. which is 1536. However, it actually does not mean that you know where the data is, because only knowing the virtual address, it doesn't help at all. So I know the virtual address, but I have to check the mapping table, the translation table, where 1536 is mapped to, where 1536 is mapped to. And according to the mapping table, then I will be eventually be able to find that piece of data. Suppose that piece of data is mapped to the hard disk. Suppose that piece of data is mapped to the hard disk. And then, of course, if the data doesn't fit into the RAM, then the page table, which is this translation table, actually has a formal name called page table. So this translation table will map the virtual address to the hard disk, and the operating system can help to load that data into the RAM as needed. Okay, so then we will need to introduce what is page table, so the translation table here, how to design the page table. And you will have, so 5-star here, okay, 5-star here. So for next video, I will talk about what is page table, how you could design the page table, and you will have one question, at least one question, simple problem, simple question, okay, in your final exam. You will have simple question in your final exam asking about page table, So 5-star, 5-star here. All right, so I will stop here for this video, and I'll talk about page table in the next video.